In this video, we'll discuss the next concept of a stability analysis, that is a critically or marginally stable system. In linear time invariant system is said to be critically or marginally stable system if for a bounded input its output oscillates with a constant frequency and amplitude. Such oscillations of output are called undamped oscillations or sustained oscillations. For example, here a marginally stable system or critically stable system means, so for stable system the output should reach the it has to successfully complete transient analysis and it has to go to steady state, then we can say that it is a stable system. But for margin, and if it is for example, if it is increasing, it is not going to constant state, it is keep on increasing the values, output values till infinity, then those systems are called as uh, unstable system. Now, marginally stable system means for any of the control system, if we plot the response, then if it gives the transient responses only, in the sense that transient response also with constant one, like constant frequency and constant amplitude, but it is keep on oscillating. So then it is not going to reach the steady state also, and but it is not increasing also, it is not decreasing, it is not increasing, amplifications will be there, but it is constant one, constant frequency, constant amplitude. So those type of oscillations are called as undamped oscillations or sustained oscillations, and that type of systems are called as marginally stable system. When the roots of the characteristic equation, now this is the, with the plot we can explain what is an marginally stable system. For example, if the characteristic equation is given, then for that characteristic equation, how to find out the, how to see the stability of the system. So for example, when the roots of the characteristic equation has a simple roots on the j omega axis and none in the right half of the s plane, then the system is said to be critically or marginally stable system. In the sense, we know that if we plot or the roots of the characteristic equation, then if we get the roots in the right half of S plane, so we study this S plane concept in the signals and systems. If we get the values, if it lie on the right half of S plane, then those systems are called as unstable system. All the characteristic roots lie on the left half of S plane, then we are calling it as a stable system. Now, if the roots are real, simple roots, and it is on j omega axis, then those systems are called as marginally stable system. Then what is the zero input stability? Next concept, zero input stability. The zero input stability refers to the stability of the system when the input is zero and this system response is due to initial conditions. Zero input stability means when the input is zero and response is due to initial conditions. The zero input stability also depends upon the roots of the characteristic equations. A system is said to be zero input stability if and only if the zero input response C of t is bounded. Zero input response C of t is bounded, and that means if it approaches 0 as t tends to infinity. Otherwise, the system is unstable. So, mathematically, we can represent this as zero input stability. If a system is said to be zero input stability, if and only if the zero input response, zero input, if either the zero input will get some response, right? So that response is C of t, and if it approaches 0, the values approaches 0 the value of t tends to infinity, then we are saying that the system is a zero input stable. Otherwise, those systems are unstable. Mathematically, we can represent zero input stability like this. So it is mod of C of t is less than or equal to m and less than or equal to infinity for all t is greater than or equal to t naught when where m is positive value, and if limit t tends to infinity, this c of t is equal to 0, then the system is called as stable system. Since the output c of t approaches 0 when t tends to infinity, and 0 input stability, also known as asymptotic stability. So when t tends to infinity, the output c of t will go to 0. Then this system is called as 0 input stability, is also called as asymptotic stability. For a system to be bounded input, bounded output stability, and 0 input stability or asymptotic stability, all the roots of the characteristic equation must lie on the left half of S plane. Just now I told, if the characteristic equation of the system, the roots of the characteristic equations of the system all are lie on the left half of S plane, then the system is called as zero input stability. So in the next video, we'll discuss Ruth Harvey's criterion or method to analyze the stability.